In this video, I'm going to talk about the intersection and union of sets. The intersection of two sets is the set of all elements that they have in common. To define intersection more formally, we can say that the intersection of two sets, E and F, is the set containing all elements that are in both E and in F. The intersection of E and F is denoted E intersect F, like this. And to write the definition of this set using set builder notation, E intersect F is the set of all elements, X, such that X is an E and X is an F. And sometimes when you first see definitions like this, it can be a lot of mumbo-jumbo symbols and so on, and it swims around in your head a little bit. So I find that to make intersections crystal clear, it really helps to have examples. So what I'm going to do is actually just erase the non-symbolic definition, and I will do some examples in this space. Let's take A and B. A intersect B is the set of all elements that both A and B have in common. B has just the numbers 1 through 10, and A has all of the even integers between 2 and 100. The elements that they have in common then are 2, 4, 6, 8, and 10. And by listing out the elements that A and B have in common, we have achieved the intersection of A and B. Similarly, let's look at A intersect D. And if we look at D, we want to just pick out the elements from D that are also in A. Those are 82, 4, 2, and 12. I wanted to write D in this way because I wanted to emphasize that sets don't have to be written in numerical order, and really order doesn't matter. It's just showing you what the collection of elements are. And similarly, I could actually have written A intersect D as 2, 4, 82, 12. So I can rearrange the order any way I want. We'll do A intersect C. C is the empty set, so C doesn't have any elements. Therefore, A and C have no elements in common. So the result in this case is still the empty set. So I left a skeleton from the intersection description that I can reuse for union. Let's start with the definition of union written out in words, and then we'll do it symbolically. The union of two sets, E and F, is the set containing all of the elements that appear in E or in F. So all of the elements get squished together into one set. So to write this out symbolically, we use this U, and we write E union F as the set of all X such that X is in E or X is in F. I need to point out that the mathematician's usage of the word or is a little different than what you are used to maybe in common speech or colloquially. When we say or, we mean one or the other or both. I will erase the non-symbolic definition, and I will fill in this space with examples of unions. Let us start with a union B. This is going to contain all of the numbers 1 through 10. A union B is equal to 1 through 10, and then all of the even numbers after 10. However, if I just write 12, 100, it won't really be clear that I'm now doing even numbers, so I will list out a few even numbers and then go to 100. That is our union of A and B. The union of B and D is going to, again, be the numbers in the list 1 through 10 and all of the numbers in the list given for D. So B union D, and I think this is just going to be easier to list out all of the elements, contains negative 100, 1 through 10, 12, 82, and 73. B union C, when we do an intersection with an empty set, we just don't end up adding anything to the other set. So B union C is just going to end up being what B is, because we have nothing from C to add into this union. So I'm going to stop this video here. There's definitely a lot more that can be said about union and intersection, so we will do that in a later video.
I don't want to grow up to be like a dinosaur, because everyone will try to scratch me.
Yeah, that probably won't happen.
And there you go, like a lot of people just being judgy.
Well,